Whether the weather is hot or whether the weather is cold, whether the weather, whatever the weather, whether we like it or not. I'll bet this exchange that we just did is probably almost identical to when we did it on whichever other episode we did it on.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started.
Welcome to lesson 92. We are in our What is Science unit. We've been going through, learning about lots of different sciences, but we're starting to get a little bit more specific. Last week we did geology, and this week, Cheryl, what are we going to learn more about?
Meteorology.
Meteorology. That sounds like fun. I mean, I'm a little biased. I like meteorology a lot.
I just think of Cloudy with a Chance of Meatballs. Have you seen that movie? Not the book,
have
the movie.
The movie, and I think there's a sequel, right?
Yeah, the sequel's better. It's hilarious. There's all the foodimals, like the shrimpanzee.
That's right.
And the Taco Dial Supreme.
Uh-huh.
They're so good. But that girl, Sam Sparks, is a meteorologist. Yeah.
Oh, okay.
And they're like, she's just a weather girl. And then, no, she's a weather scientist. And she gets all nerdy and excited about the science going on with the weird
I forgot about that
machine. I've seen them a lot. They're very funny.
I could see that those would be your kinds of movies.
Yeah, they're pretty goofy.
Yeah. Well, let's get into the pre-assessment to find out beyond Cloudy with a Chance of Meatballs what you know about meteorology.
So little. I think we've established on this podcast how little I actually understand weather. And so I think the majority of what I know about weather is from this podcast, perhaps.
Okay. Well, let's just take one step back then. Meteorology is what?
The study of weather.
Okay. Continue.
I'm assuming it's specific to our planet. Otherwise, is it astronomy?
Okay.
If you're studying Jupiter's weather, are you an astronomer or a meteorologist or both? These are the questions. And then you're going to ask me what I think that meteorologists do.
Sure.
And I think that they give me the information on my phone that shows me the hourly forecast that helps me decide whether I'm going to wear a rain jacket or a pea coat.
Okay.
So I'm thankful for meteorologists because that's helpful.
Yes.
I'm guessing they study weather patterns. It sounds probably similar to what we were talking about with geology, where they're looking at history to see patterns, and then they're also forecasting ahead to see like what's coming.
Why did you laugh at that?
Because of the weather forecast. It's not much of a joke because we're talking about weather, but it just made me chuckle because I was thinking about the weather forecast.
Right.
Are these the people who would have influence on the Farmer's Almanac? Because I think that's predicting conditions for the coming year as far as that will help farmers know, like growing seasons and things like that. I think they probably know more about El Nino than I do.
Okay.
Yep. I don't know what else they do than like share information about weather and work for weather stations, or you know what I mean?
When you say weather station, what do you mean by weather station?
Like news providers. I'm guessing there's other professions in meteorology, but I think it's probably still just about looking at the weather.
Okay.
This is more narrow, but this is more narrow on purpose, right? Than like what is biology and what do biologists do?
Yeah.
Yeah. I don't know what else to say. Do you have questions for me?
I do. This is not a super important one, but in thinking about meteorology, I have to ask the question. The name itself, Meteorology. Where do you think that name comes from?
I don't know, it feels really random because a
Why?
meteor comes from outer space.
Okay, and do you think that falls into meteorology?
Oh, probably. Has an impact, I'm sure, on our
It has an
conditions.
impact.
Ah, um, but I don't know. I don't know, like, the
Okay,
origin of the word. No,
okay. That's okay.
thanks.
Well, Cheryl, let's start with just the name, meteorology, and where it comes from,
Okay,
shall we? Yeah.
yeah.
Meteor, you did kind of get that out of there, right? Meteor, like a thing that's falling from the sky. Well, it's
Oh, things that are falling from the
things
sky.
that are falling from the sky.
Okay, we
Yep,
got
yep.
there.
Now, we're pretty sure it was like Aristotle, I think, who initially came up with that term way back when. And I'll link to an article in our description that goes into a whole lot more detail about where it came from and things. But it's not really meteors in the same sense as astronomy meteors. It's more
Okay,
just things that are up above. And that's sort of where that root comes from in the Greek. And so it's the things that are up above, which are usually going to be, things that are weather like or that influence weather. So there you go.
nice.
So meteorology is typically the study of weather on Earth. You can study weather on other planets, like you implied, but generally that would be considered part of astronomy. You might be considered a planetary scientist in that sense. You could study
Mm,
the meteorology, and you may have a background in meteorology on Earth because a lot of the things that we know, we apply those ideas that we know about here to other planets and vice versa. That's actually, and now I'm getting off in astronomy, but that's part of why studying other planets is helpful. It gives us another use case to understand what's happening here on our
oh, yeah.
planet,
Yeah, that makes a lot of sense.
right? Like, is this unique to Earth or is this the way it happens all over the place? For example, there are dust devils on Mars. Mars has dust devils, just like we have here
Mm,
on Earth, right? And that's like a weather atmosphere thing. As far as what exactly meteorologists study and do, yes, a component of that is related to your weather forecast on your phone or on the news or whatever. That's definitely a component. But just like with geology, which you referenced earlier, there's a
mhm,
ton of other stuff that they're doing. A lot of it is research. They're trying to
mm,
understand how and why these things happen the way that they happen. Let's think, for example, hurricanes. Some of the people who are
yeah.
studying and tracking hurricanes are not directly making the report that is going to be on the news. There are people who are doing that,
Oh, okay.
but they're not necessarily doing it. They may be just studying the mechanics of hurricanes. How do hurricanes work? What causes them to get stronger? What causes them to change direction? When, like, how can it go from, a category 4 to a category 5? And then taking those things that you learn and plugging them into computer models that then help make the predictions for that specific hurricane and what is it going to do.
That's so cool.
Does that sort of make sense? How it's
Yeah,
not directly the prediction that you would see, but it is sort of related.
yeah. They're doing a lot more of, like, the legwork of it
Yeah.
then so that there's, like, a foundation or more like a summary for somebody else to reference from.
Yeah. I
Okay.
don't know if you have noticed in your lifetime. I have definitely noticed that weather predictions, especially here where we live in the Pacific Northwest in kind of the greater Puget Sound, Seattle area, weather forecasts have gotten much more accurate in the last maybe
Yes.
10 years or so than they ever used to be
100%.
growing up.
Yeah.
Yeah. Especially when it comes to snow. Have you noticed
Yeah.
that?
Yes. Yeah.
The joke growing
Absolutely.
up used to be if they're confident it's going to snow, then it won't. And if they're sure it won't snow, then it will. Because they didn't used to
Yes.
be able to predict snow accurately.
Mhm.
And
Yeah.
part of that's because here in the Pacific Northwest, we've got some really unique things that make it very difficult to predict snow, because we've got so many
Really?
mountains and hills and
Mm,
gullies and all sorts of different weather that can come from lots of different directions to be able to make and produce snow. But we have really dedicated meteorologists who have been studying what causes it for so long and have so much data that they've been able to refine those computer models so that now their predictions are so much more accurate.
that's really cool. I love that.
Yeah.
That's really neat.
Yeah. Can I just take a little tangent for a minute and tell you some of the cool things about the weird weather where we live?
Yes, because I know so little about weather and sometimes care so little about it. So I need you, just like with chemistry, I need you to like get me a little bit more excited
Okay.
about weather.
Okay.
Yeah.
So this is something I think is really, really cool because, like I mentioned, we live in the Puget Sound region of Washington State, and it's fairly unique in a lot of ways. I'm not saying that there's nowhere else like it, but there's a lot of unique things about how it all comes together. So Puget Sound is a waterway that was carved by a glacier. That's little geology there, but it was carved by a glacier. So it's got all of these weird islands and inlets and all sorts of different things, and it's funky shaped, right? Well, it's basically a valley. Okay.
Oh, yeah.
Just to the west of us, we've got a mountain range, the Olympic Mountains. Our weather, because of where we live, typically comes off of the Pacific Ocean. It usually comes from the west to the east. Are you tracking with me
Is
so
that
far?
not true everywhere?
No, it's
Oh,
not.
I didn't know that. I just know
Yeah.
where it comes for us. So I thought that's just
Yeah.
because of the way the
And
world spun.
it is related. Oh, look at you. It is related to the way the world spins. Okay, sorry. I'm not going to finish any thoughts here. I'm going to take another step back. Foundational idea here. And this should probably be in the pre-assessment, but I'm just going to do it now. What drives or powers the weather for the entire planet?
The wind,
What powers the wind?
the world spinning.
No.
What? Did
The
we talk
world
about this in
spinning.
our wind episode? We did.
Maybe. We might have.
Pressure, pressure, pressure
What
fronts,
changes the pressures? Why isn't it all the same pressure?
temperature,
And what changes the temperature? We're going to get there.
the angle,
Of?
the earth compared to the sun.
There we go. You're just throwing things
Oh,
out there.
no. So the sun.
The sun. The sun's energy is what powers all of our weather. All of it.
Oh, well, yeah, that makes sense. I just didn't think about like, I was thinking, yeah, okay, now that makes sense.
Yeah. Right. And so and I'm pretty sure we talked about this, that at the equator, you get the most direct sunlight, which
Yeah.
heats the surface of the earth, which then heats the air that's next to it, which causes it to rise. Right. It expands, it becomes less dense, it rises up. So you have all these air currents going up, and then they reach kind of the top of one layer of the atmosphere, and then they start to spread out. Did we talk about this at all?
A little.
A little bit. Let me see if I'm gonna see if I can find a picture that would be helpful. All right. Can you see this?
Ooh, yeah. So I see the globe, but all
Mhm.
sorts of colorful lines and
Yep.
labels on
Yes.
it.
Yes.
Arrows.
Have we looked at this at all?
No.
Okay. All right. So along the center of the earth is that green line that's marked 0 degrees. What is that?
The equator.
Yay. Yep. So that's the equator. Again, in that region is where you have the most intense sunlight most of the time compared to the rest of the earth. Does that make sense?
Yeah.
Okay. So you've got the most heating there. If you look over here on the right side of the diagram, right near the equator, see how you've got these kind of loops with these circles with arrows?
Yeah, there's like segments of them around the globe.
Yeah, those are representing overall the way the air is moving for each of these regions. So near the equator,
Whoa.
the air is moving up, just like I said, right? Because it's
Yeah.
heating up, so it's spreading out, it's becoming less dense, it heats up and then runs into kind of the top of our part of the atmosphere and then spreads out to the sides. So it spreads up north and then also spreads down south from the equator. Is
Yeah.
this making sense?
Yeah.
But as it moves there, eventually that air starts to cool down again. And when it cools down, the molecules get closer together, it becomes more dense, and it sinks.
Yep. That makes sense.
Okay. And so then you see you've got air that's sinking. And then that air sinks and then gets pushed out along more closer to the surface of the earth. So it goes up, it comes down. There's also stuff going down there, and it pushes on both sides of that. Yeah.
Yeah.
Okay. And then you got another cell that we call, each of these is a cell. You can see the names here on the left-hand side.
Oh,
So the
wow.
Hadley cell is the name of the ones near the equator. You got the mid-latitude cell, or I think of the Ferrel cell, or Ferrel cell, I think is another name for them. And then you also have polar cells, where at the poles, now you've got the coldest air is near the poles. That makes sense?
Yep.
Right? So it, again, coldest air, molecules close together, denser, sinks, gets pushed around. So you've got each of these different cells, and they're mirrored in the northern hemisphere and in the southern hemisphere. Okay? That is the big picture motion of the air on Earth. Then, depending on which of these zones you are located in on Earth, depends on the way your predominant winds blow and the way the weather tends to move. And so notice they're called the trade winds, which you've probably heard of before.
Yes. Yes.
In this zone between about 0 degrees and 30 degrees, either north or south of the equator. We don't live in that zone. We live north of that zone.
We live in the westerlies zone.
We do.
That's
We're
the
in the
cutest one.
westerlies. We're in the westerlies, which is between about 30 degrees north or south and 60 degrees north or south. That's where we're in. Also, Europe is there. So you'll notice like that, right? And then if you look at kind of in the southern hemisphere as well, that's farther down. Australia, if we were to flip that around, it's going to be part of it's going to be there, New Zealand, things like that. And so westerly is because that wind tends to blow towards the west, which is why our weather tends to come from the Pacific Ocean, because that's to the west of us. See how it's all connected?
Yes.
Now,
Wow.
something you mentioned earlier that is related to this, the reason why some of these cells go to the west and some of them go to the east is because of the spinning of the Earth. So the spinning does have an influence. It's not that doesn't affect it at all. It does. But that's not what's driving the initial motion. Does that make sense?
Yeah, that makes sense. Yeah, yeah. It's a secondary reason
Yeah.
behind that. That is
Yeah.
so cool.
So we took like 3 levels away from your original question. I'm trying to work our way back. So
Yeah.
that's why our weather comes from the west, but
Mhm.
not everybody's does.
Yeah,
Good?
that's really cool.
Okay. Now for the Pacific Northwest, remember this is where we started? Okay.
Yep.
We've got weather that comes off of the West Coast, but it runs into the Olympic Mountains because those mountains are not very far from the coast, the Pacific coast.
And
You've
that's
been
why
over
there's
there
a
before.
rainforest there.
That's exactly why there's a rainforest, because that air that came over the water has a lot of moisture in it because it's been over the ocean for a really long time, been able to absorb lots and lots of moisture. As it approaches a mountain, it goes up. That air mass gets pushed up because the mountains are in the way. When that happens, that air gets colder because it's getting farther away from the surface of the Earth. That causes that what used to be a water vapor to be colder to condense into a liquid and rain. And it dumps all sorts of rain. And the reason we have a temperate rainforest is because of those mountains right there, because that rain is forced to drop there.
Yeah.
And then that air comes over the Olympic Mountains and down the other side. And as it's coming down, it warms up, it spreads out, it dries out, which is why we have areas called rain shadows. You may have heard of that before.
Yes. Yeah.
Like Squim is talked about as a rain shadow for anyone who's local to this area. What happens is because of that air coming down, it actually rains very, very rarely because that air is not very moist anymore.
Yeah.
It's dried out. So it's in a rain shadow, literally a shadow where there's no rain. But what do we have on the other side of the mountains?
More mountains? Oh, more water.
before
and then
that.
more mountains.
Exactly. We've got more water in Puget Sound that can pick up more moisture and then head over this way. And look, there's more mountains, our Cascade Mountain Range, to go up and drop the rain again, which is partly why we get so much rain and moisture in Seattle. Now, so much rain, that's why it's wet a lot anyway.
Yeah.
Right? And
Yes.
then you've got another set of mountains, and then you go down the other side to central
Eastern
and
Washington
eastern
is
Washington.
a desert.
The parts of it are a desert.
Mhm.
Again, same thing. It's dropped in by the time it gets to eastern and central Washington, it's actually dropped its moisture twice. Once with the Olympics, and then again, got a little bit more from the Puget Sound, but still dropped even more again going over the Cascades. So that makes that in and of itself is pretty unique. Well, then you also have this thing you've heard of, probably the convergence zone before.
I've heard that word.
Yeah. So some of the air coming off the Pacific doesn't go up the mountains. Some of it gets pushed around the sides of the mountains. So up the north and down around in the south. And so some goes through the Strait of Juan de Fuca to the north of us. Some goes down south of the Olympic Mountains, right? So the southern part of the state. But then it comes back together at Puget Sound. So you've got some air, sometimes it's coming down from the north, sometimes it's coming up from the south. And if it meets, it's going to run into itself, up it goes, it starts to make clouds and can start to rain.
Oh, wow.
Or snow if it's cold enough. And if the air coming down is coming down from Canada, they talk about the Fraser River Valley, that's where often we'll have really cold air that's required to get it cold enough for us to have snow. But all of these factors with weather, like just air coming from all those different things, and that's assuming it's all like the same air. But if air is not all the same, it might be warmer or colder or have more moisture or less. That's one of the things, that's sort of those pieces, big picture, that make where we live pretty unique and more challenging to predict some of those weather things sometimes.
Yeah, that's so interesting. That's dramatic.
It is dramatic. Okay, that was, I'm stepping down now.
While you're stepping down, I would like to sing you a song. Ryan.
Okay, sure.
I mentioned this in maybe our first episode or maybe a very early episode. I don't remember quite when. In 4th grade, we did a weather unit, and
yes,
I don't remember anything from the unit other than parts of 2 songs.
Parts of 2 songs. Okay.
Yes. Yeah. One of them was called Wacky Weather. I think that was
like
probably
maybe
the
told
intro song that we learned about or something. And then they got more specific after that. But some of the lines I remember from Wacky Weather that still get stuck on my head quite a lot. It was like, Wacky Weather, what you doing? Can you tell me what's a brewing? Will it rain? Will it shine? Then I forget some lines. And then it was like, who can tell me what's in store? Is that what a weather map is for? And then it got like a little funky because we're talking 90s here. So it's like wacky weather. And then the other song I also think about every time someone says the word precipitation, it was called Precipitation. And the chorus, I think, was like, precipitation means it's gonna be wet. And then I don't remember many of the other words other than the end of the song went, precipitation means it's gonna be, yes, it's gonna be, means it's gonna be wet. And whenever someone says that word, that's what happens in my brain. There's also some line about rain, sleet, hail, or snow in that. So we learned about what precipitation, our options were.
Hey, Cheryl.
Precipitation too. Yes.
Can I share something with you?
Yes.
I just did a quick little Google search.
Oh no, did you find it? The weather wrap?
That's what it's called.
Oh. Is this it?
You tell me.
Okay. I have not heard this since 4th grade. Yep, 100%. It's funky.
There you go.
Oh my gosh. Weather rap is generous for whatever that is.
I would not call that a rap. No, but there you go. There's the song. I figured it's like,
I'm
hey,
so
we have the internet.
happy. Oh my gosh. Exactly how I
You
remember
did sing
it.
that for us before. I don't remember
Yes.
when.
Yes, I don't remember either. We've done a lot of episodes.
We have.
Yeah.
Did I then tell you the weather rhyme, for lack of a better word, that
I don't
learned?
remember a
Oh,
weather
we
rhyme.
did.
But maybe that could become the weather rap because a rhyme sounds more like a rap than whatever the wacky weather song was.
Maybe.
Just saying.
Well, here, I'll tell you the one that I learned in second grade.
Okay, amazing.
Okay. And whether or not this is actually what it is, I don't know. But this is the one I remember. Okay.
Okay.
You ready?
Yes.
Whether the weather is hot or whether the weather is cold, whether the weather, whatever the weather, whether we like it or not.
I've heard that before. I don't know
Oh,
if
okay.
you told it for me before, but
Probably.
I've heard that.
I'll
rhyme
bet this
before.
exchange that we just did is probably almost identical to when we did it on whichever other episode we did it on. That's my
Although
guess.
last time you did not find the song, so now I'm
I
very
did not.
excited
That's true.
that you found the
That's
song
right.
for me.
Yep, there's a
Yes.
bonus now. Yeah.
Yes.
Yeah.
Oh my goodness, that's hilarious.
Well, we've talked a lot about random meteorology weather things. Are there any lingering pieces that you would still like me to kind of address or clarify for you?
Okay, so I know the answer to this now, so this is not a question, but more of a fun
Okay.
fact is
Okay.
that I did not know it was possible to have lightning without rain until my adult years because of where we live.
Lightning without rain.
Yeah. Where we live, when there's lightning, like there's rain.
Mm.
And then in my adult years, I was somewhere else and there was lightning and no rain, and my mind was blown.
Oh, interesting.
Yeah.
Interesting. Okay.
Probably because I slept through science. So, you know.
I mean, maybe that might have something to do with it. I don't know. Now, Cheryl, we're going to find out if you slept through this science lesson by giving you a quiz.
I can tell you that my eyes were open the whole time.
That does not mean you are awake. You and I both know that. Alrighty. First of all, what powers or drives all the weather on Earth?
The sun.
Woohoo! Way to go. Way to go.
Yay.
Why do we call it meteorology?
Because it's about things falling from the sky.
There you go. Things that are in the sky.
And something about Aristotle.
And something about Aristotle. Yeah, great.
Yeah.
Other than reporting the weather to us, what are some things that meteorologists do?
Sounds like a lot of research
Mm-hmm.
where they're tracking things so that they can learn more.
Yeah.
To be able to predict the next time things are happening.
Yeah.
What they're going to be doing.
That's great. Yeah. There's other things that we didn't even talk about too, that like historical, just like we talked about with geology. So looking at past climate and, climatology, all of that stuff, studying our current climate, past climate, making predictions for future climate, all that stuff as well, which we didn't really even talk about the difference between climate and weather, but we'll have to do it at another time.
Oh boy.
I know. Next question. What are two unique things that affect the weather in the Puget Sound region?
Ooh, well, double mountains.
Okay.
And double water. And those are the main things.
Okay. Yeah, that's great. Double mountains and double water. I like the way you talked about that. That's good. That's good. What creates a rain shadow?
Rainfall before it gets there. But what we talked about more specifically was a mountain range where all of the wet, moisture-filled air hits or goes up and then
Hmm.
causes rainfall, and then the air just doesn't have a lot of moisture when it
Yep.
goes on the other side of it.
Yep. Yep. And usually it is because of mountains. It's not like,
Mm,
oh, it just rained. Like there's a reason, it has to have a reason to rain in one spot and not in another
yeah,
regularly. Right?
yeah,
Like you can have like, oh, there were like rain showers here in this city, but not in that city or whatever like that. But over time, it's gonna even out. But if you have a
yeah.
rain shadow, it's consistently not receiving that rain. So
That makes sense.
yep. Yep. And finally, explain why we have different cells of moving air on the Earth.
I do remember this type of cell when you said that. Well, it really starts at the equator because
Mhm,
the equator gets the most sun.
mhm, mhm.
Um, and because it gets the most sun, it has very hot air there. And we all know that heat rises, which why any household has
Heat doesn't rise.
hot air rises.
Mhm.
There we go. Which then why any household has heaters in their ceilings is beyond me. But
Yeah,
um,
yeah.
that's a different issue. Um,
Mhm,
so since the hot air rises, then it starts going north and south because it has to go somewhere. Uh,
mhm,
and then from there, eventually it falls as it gets colder. And the air that fell goes in like both directions again. So it just creates these like symmetrical patterns on both sides of the globe that create all sorts of fun trade winds.
there you
Like the
go.
westerlies, which sounds like a storybook term for
It
winds, so
does.
I like it a lot.
Yeah. Now the trade winds and the westerlies are different though. You got that?
Ooh,
The
I thought the
trade
westerlies
winds,
were a classification of trade wind, but they're not. There are trade
they're
winds and then there are westerlies, is what you're
yes.
saying.
So the
Okay.
trade winds are the winds that are in between 0 and 30 degrees, either north or south. The westerlies are between
Mm,
30 and 60 degrees,
okay.
north or south.
Well, we have the cute ones, so that's good
We
to
have the cute ones, so it makes you happy, right?
know. Yeah.
Yeah,
Yes.
it's perfect. Great. Wonderful. You passed your quiz, Cheryl.
Yay!
Congratulations.
Amazing.
Amazing. But that's all the time that we have learning about meteorology for this week. So please go ahead and pack up your stuff and get ready for my closing remarks.
You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you, I dismiss you.